Let us re-examine what is this Wheatstone bridge is. So when we say Wheatstone bridge, there are two ends. Let's say this is end A and this is end B. And there are two arms of resistances emerging from end A. Let's say this is one, this is another. From B also there are two arms of resistances which are emerging. So let's say this resistance is R1 and this is, let's say, R4. And from B also there are two resistors which are emerging. Let's say this is R2 and this is, let's say, R3. And remember, these two resistors which are emerging from A and B, they are joining each other. Let's say at the end C, and similarly R4 and R3 ends are joining each other at the end D. And C and D are also joining each other by some other resistance. Let's say R5. This is said to be Wheatstone bridge. So from A there are two resistances, from B there are two resistances, and they are joining each other via fifth resistance. That is going to be Wheatstone bridge. Now this Wheatstone bridge is said to be balanced if R1 upon R2, and R4 upon R3, if this ratio is same, then Wheatstone bridge is said to be balanced. It will be balanced. What does it mean balanced? Balanced means if I apply some potential difference across A and B, there will not be any current through this fifth resistance between C and D. There will not be any current through it. That is the meaning of balanced Wheatstone bridge. So let us examine this one for our next question, which is going to be question number 41, where you see they have drawn a triangle type of figure. So you can see that you have this one side of the triangle, this is another side of the triangle, and this is another side of the triangle, and somewhere at the center there are three resistors which are emerging. One is this one, and the other is going like this, and this is also going to that third vertex, and they're all equal. Let's say this is R, this is R, this is also R, this is R, this is R, and this is also R. So if you examine between A and B, the equivalent resistance, excepting this one, this R, if you forget about this R, you can see from this end there are two resistors which are emerging. Similarly from this end also there are two resistors which are emerging, and these two are joined at these two ends. You can call them C and D, and there is some resistance across C and D also R. So it looks like very much this part looks like the Wheatstone bridge, and it's a balanced Wheatstone bridge because the ratio of R upon R is going to be 1 only. So it is going to be balanced Wheatstone bridge, and you can simply remove CD from it. You can simply remove this resistance across CD because there will not be any current flow through it. So what do you expect? If I remove this one, it simply becomes 2R because they are in series now. This is also 2R, 2R, and this R, they are in parallel. So the equivalent resistance 1 by R will be equal to 1 by 2R plus 1 by 2R plus 1 by R. So you can simply calculate it. 2R, 1 plus 1 plus 2. So this is going to be 4 divided by 2R, and R will be equal to 2R divided by 4, it will be R by 2. That means if it is R, then the equivalent resistance will be R by 2.